Alright guys, today we're going to be taking a look at this op-amp problem. Let's jump right in. We're going to start with what we always write down when we start with op-amp problem, which is our basic op-amp rules. And those two is that Vn is equal to Vp. We also know that In is equal to Ip, and both of those are just going to be equal to 0. And those are all coming in right here at these terminals here. So Vn, this is In, Vp, that's IP. Alright, let's start with KCL at Vp. We're going to start here just because it seems to have the most going on. We can see that we have a voltage source here, which is going to help us to determine a final number, which is really going to help us out in the long run. So Vp is going to be this node right here. We're using KCL, and KCL states that the current coming in and the current coming out of a node must be equal, or when you add them all together, they must be equal to 0. So we have two currents coming in here. We're going to label them coming out just as convention. We have this current here, and we have this current here. Let's start with our top right current here. Let's do KCL, and we're doing KCL at Vp. Alright, so first we're going to have Vp minus 5 over that 20,000. Moving on to our second current, we have no voltage rise or drop, and we're going to ground, so that's going to be equal to Vp over 10,000. And remember, because this is KCL, those are both going to be equal to 0. We can do some quick algebra here to get rid of these annoying numerators by multiplying out, and that's going to get us Vp minus 5 plus 2 Vp still equal to 0. All we did there was just multiply both terms by 20,000 and get rid of those denominators. Some more quick algebra will get us that 3 Vp is equal to 5, which gets us a final product of Vp equal to 5/3, also equal to 1.67. Alright, so now we know Vp. What we also now know is Vn, because Vp equals Vn. So let's move up and do KCL at Vn. Now we're looking at this node right here. Once again, we have two currents coming in and out, or going out actually. Technically we have another one, which is In, but that's 0, so we're going to ignore that for now. We have this current coming up here, and this current going here to ground. Let's start with the one going to ground. That's going to be a simple equation. We just have Vn over 10,000. To our second one, we're going to have Vn minus Vo, which is the voltage at this node, over 20,000. Because again, it's KCL, we know it's going to be equal to 0. What we're going to do now, another simplification, multiply through by 20,000 to get rid of these denominators, which is going to leave us with 2 Vn plus Vn minus Vo equals 0. From here, simple algebra, to get us to 3 Vn is equal to Vo. Now remember, this is the key part here, we know what Vn is, because Vn is equal to Vp, and we've solved for Vp using KCL at that node. So we're just substitute that in real quick. That's going to be 3 times 5/3 is going to be equal to Vo, which is just going to be equal to Vo is equal to 5 volts. This is volts over here as well. Now we have both of our answers. Remember, the only two steps, really important steps for this one is to note it, so you're going to want to do NVM method KCL at Vp, and then remember this key step here, that Vn in an op amp is always equal to Vp, and that'll get you the rest of the problem. Alright guys, thanks.